Hello everyone, in this video I want to explain about the pointers with array. Now, so this is a basic statement here I have declared. Declare one array. Now followed by there is a one pointer variable also integer type and along with a one variable b. Whenever we want to store a address of a variable in a pointer, so what is the notation we are using? We are using a notation pointer is equals to pointer address of b. So this is the basic notation we are using because b is a normal variable, but this time we want to store a base address of base address of a array. So now what is the notation we should use? So in this uh, whenever you want to store a base address of a array, just we have to mention the name of the array. So the name of the array. Why we should only mention the name of the array? Because a is the name of the array. By default, which itself it carry a base address of a array. So that no need to mention the address of operator. Array name itself it carries the base address. So that no need to mention the address of. Whenever you call a address of, which means it is a address of array. So, but already there is a address is there inbuilt with the array name. But we should not mention the again address of. Again address of we should not mention. Just to mention pointer assign a name of the array. Now what could be happen? The first address of the array assigned to the pointer variable. Now, how many elements are there in the array? There are four elements are there. Out of them, we got only the first address. That is, we have zero element address only we got. So whenever you want to print any value from any value by using the pointer, you will get a first index, zero index only. So you won't get a next index value. So that to get a next index values, we had to follow we had to follow a concept. What is that concept? So first one, I want to try to print a first element. Whenever you want to try to print a first element, so this is the percentile d followed by the AR. So this I want to give a pointer. Pointer nothing but to get a value, we had to use a indirection operator pointer. So now you will get the output as a 5 because it is a base address. So you will get the output as a 5. But here I want to print a second element by using the same pointer. For that we had to transfer this pointer address to the corresponding second element. What is the process we should follow? So here we have a alternate notation to access the next element. Okay. So what is the notation we are using? So in this so now just I want to use a point a percentile d comma pointer. We want to go to the next index. How to reach the next index? To reach the next index, we have to do the two things. The first two things I will explain here. So where you want to move, I want to move to the next index, so pointer, and also I want to access the next index value pointer. So PTR will provide the base address because there is a 2000 still there. That address I want to add a 4 byte of memory because every 4 byte of memory we have a new element because integer it is an integer array. First index base address is a 2000, second index base address is a 2004, third index base address 2008, fourth index base address 2012. Nothing but everywhere in every element which carries the 4 byte of memory because it is a integer type. Now I want to increment the 4 bytes. To increment the 4 byte and it is the refer to the pointer pointing the integer array so that just you keep 1, nothing but plus 1. Plus 1 means it increments the one index forward. One index, it is increment the one index. It is also equal to the meaning. What is the meaning? Exact meaning is this pointer. What is the base address? Base address is equals to 2000. Now 2000 plus one index. So now we can say it is a size of. It is a size of one integer. One integer value will be added to the base address. Base address means it is a pointer. So how much it is? It will become a 2000 plus 4. 2000 plus 4. So which is equal to 2004. 2004 is become a value. Now what is the exact meaning we are carrying here? So what is the value? Pointer plus 1. It is equals to same pointer variable. The pointer nothing but the is stored in address value get increment by the 1. The increment of how much? How much? It is a one integer size increment completed. The same thing if you want to go to the next index value. I want to shift to the second, third, means it is a index number 2 means it is a third element 2008 I want to reach. Then what is the notation format we should use? We should use the pointer plus 2. Pointer plus 2. Pointer has the base address. That base address plus 2. 2 nothing but that is a 2 into size of integer. How much? 2 into 4. 2 into 4 nothing but it is equal to the 2008 address. It is equal to the 2008 address. For the next time you want to use the pointer 2 plus pointer for the next value. For the next element, if you want to reach same process, increment the pointer. Always pointer store the base address. For the base address, we had to add the element wise. Element nothing but it is a integer element. Always which multiply with a that element number into size of integer. So you want to reach the next third element. So then simply you have to go multiply with 3 into size of integer. So which means 2000, it is made at 12. So like that, we are able to reach the index by index after by incrementing the pointer value. But pointer increment, which means it is not a incrementing as a 2001, 2002, not like that. It is always increment size of the data type. Size of the data type for the integer it is a 4, so that it is every time it is incremented 4 byte. So this is a notation we have to use. Okay. Similarly, if you print the next value pointer, so what is the value will be printed by using this statement? The statement will print the 10 as a output. 10 as a output. Similarly, let's see the same kind of thing in the slide. Here a pointer, it is just you have to mention the address. Not sorry, just you have to mention the name of the array. No need to mention the address. Because pointer name itself is the base address. Now this pointer is pointing to the base address. Now I want to in this corresponding slide, I just explain about how we can able to move from one index to the another index by incrementing of a pointer address without using any for loop. But the same thing we can able to do by using a for loop. So how we can able to do how many iterations you want to perform? I want to perform the 4 number of iteration because there are 4 elements are there. I started with 0th number iteration, less than 4 nothing but we are moving from 0, 1, 2, 3, total 4 iterations will be complete. So we are every time we want to print the value at the corresponding location. So normally, if you want to print address, you know that PTR we have to here use the percentile U. Print address, that is for address, not for the value. If you want to print the value, we have to mention the indirection operator. So whenever you print this one, we should always mention the base address. You can always mention the base address. So whenever you call it just a pointer, it's always available with the base address. So you will get a 0th index value. But now I want to go to the next index value. Get the next index value, you can also use the this kind of notation. Pointer plus plus. What do you mean by the pointer plus plus? Pointer plus plus also means a pointer pointer plus, which is also meaning like pointer plus 1. Okay. So pointer plus plus also increment the pointer address with one integer size. So you can also use this notation. You can also use this notation, increment. So basically, increment is applicable to only increment the address. If you perform like a pointer PTR plus plus. Now see the difference. It is one of the great question. Whenever you increment the pointer base address, which means it is a 2004. But if you apply increment with indirection operator, which means base address value, what is the base address value? 5. It means a 5 plus 5 plus plus. And it means it is a 6 value. Okay. Increment operator applied on a value at this address. So value, because indirection operator with base address, it is becoming value at this address. Value at this address will get increment. Whenever you apply base address increment, it means it is increment with one integer size. So this is a difference we have to remember because increment operator will always confuse. Increment operator with the indirection operator will apply the increment on the value at this address. If the only increment on base address, then we increment the one integer size with the base address. So this is a different we should remember. Now coming to the point, now we are applying the increment the address. Whenever you are incrementing the address, which automatically change, and also you should remember, whenever you apply these corresponding notation format, which cannot affect the stored value of a pointer. Always pointer base address will become a 2000, any time, 100 times you increment p plus 3, pointer p plus 4, plus 5, plus 6, always but base address of a PTR will become 2000 always, cannot be changed. But whenever you apply PTR plus place, what could be happen? Base address will be changed from the pointer. So now whenever you apply pointer plus place, it's shifted. The pointing address will be shifted. So now it is obviously pointing from here onwards. You can use the notation whenever you need. Uh, Basically, we should follow this kind of notation, which cannot modify the pointer base value. But whenever you go to this kind of pattern or this kind of increment, which obviously modify the pointer stored value, which already become a 4. Now you will get a next time it is going to be printed 10. So whenever again it is after printing 10, in the next iteration, again it is incrementing. Whenever again it is increment, the value will become 8. Now it is shifting pointing to the next value. In the next last iteration, what happened? Print the value and coming to the last iteration, pointer plus plus, which means again it is become 12. It become 12. It's already been changed. Now it is going to be pointing to the corresponding location. Address increment also affecting stored value of a pointer. Now what is the stored value of a pointer after 4-time increment? The pointer value is becoming 2012. The pointer stored value is becoming 2012 address. It is a base address for the fourth element. Whereas coming to this that I have explained on the paint, the base address never it can be changed. We are just to increment the address and pointer value could be changed, and we are able to reach the index to the index. So that is the difference. Based on your need, you can able to either use this notation or that notation. Next one. This is one more example. So that what I have explained in the paint, the same thing available here. Whenever we are adding zero nothing but we are not adding. So base address will be access, so 10 value will be print. Whenever you increment by the 1, which increment is 4 byte of memory and reach to the next index. So now the corresponding value will be print. Pointer base address plus 1. It is become a 2004. 2004 location address is become value is become a 20. If 2008 value will be print. Okay. In this case, the pointer base address cannot be changed, cannot modify. Only we are shifting pointing value from one location to the another location, but the base address of pointer will not be changed. The next one is to I think you understand this kind of notation. This is mostly we are going to be prefer to use this kind of notation. Okay, to access the array elements or to reach the index to index addresses. Okay. So all those things we can able to do. You can iterate over array using a pointer arithmetic like a pointer plus plus also. Now let us practice one problem. That is it is a problem to read the values and print the values. Now there are 5 elements are there. Here we have a 5 elements. Now we are assigning this pointer value to the corresponding base address. Base address of an array. We are assigning to this pointer. Okay. Now this pointer is pointing to the 100 array of zero element. So we want to access the element by using. So first, let me explain. This is a different kind of notation. This for loop, and this is a one more kind of notation. Okay. Let me explain this. First, let's come to this one. We already had a practice on this kind of concept. I is equals to 0, I less than 5, I plus plus. We want to print the value by using this kind of notation. Pointer base address plus I. First initially base address plus 0 to 0th element. Base address plus 1, first element. It is incrementing 4 byte every time. We are reaching according to the base address of every index element. So this is the notation we are already discussing. But coming to this point, coming to this one, here we are processing the same array. What is the name of the array? ARR. We are processing the corresponding array with a PTR. Remember, once the pointer is allocated to the array, now we can use, instead of the ARR name, you can also use a PTR. This is an alternate process for to access the array element by using a pointer name. Okay, so how we are accessing, just instead of the array name directly, you can also use a PTR name. Because what you mean by the array? Array itself inbuilt which has a pointer. Always we identify the base address. Now what we are storing in this array? We are storing the base address. Now in this case, pointer is become a array. Array become a pointer. So that instead of the array name, we can directly use a pointer name. Okay. So you can also use this process. You can also use the pointer plus increment decrement process. And also we can directly use a pointer variable instead of the name of the array. And normally we can able to call index value. What could be happen? Whenever you call 0 index base address, whenever you call 1 index, which increment the 4 bytes and increment the shows the next index like that. Okay. So next, we are printing exclusively if you want to print a third element. 0, 1, 2, 3. Nothing but it is a fourth element. Actually, you can able to increment use this kind of notation. So this one just print the array elements in a different way of format. Next one, so we want to point to the first element. So this is the first notation. Next one, we are printing the corresponding notations. So printing by using this notation format. So now we want to print the address. We want to print a address of a element by using a pointer with array. You can also use a percentile U or else percentile P. So by using the print in the printer, if you use a P, we also use it to print the address in that address in print line. That is a pointer P, sorry, percentile P. You can also use a percentile U. Anything we can use. Now, I nothing but corresponding element, the respective address. If you want to print the address, PTR plus I. So if you mention the corresponding indirection operator, you will get a value. If you not mention this indirection operator, you will get a address. Okay. So with that concept already I have explained several times in previous videos. Indirection operator, when you start using the indirection operator, obviously which is you try to access the value from that corresponding address. So if you don't use this indirection operator, you will get address directly. Okay. Next one, sum of array elements by using pointer concept. Sum of array elements. So the program is started from here. There are 4 elements are there. Okay. I want to find out size of this array. Whenever you look into this array, there are the size of array is a 4. But we can also find out the size of array in another way. So what is the size of array? Total size of array is becoming 12. Oh, sorry, 16. 4 element, 4 into 4, 16. 16 by base element. 16 by 4, 4. So total size will become a 16 by a 4. Like that, you will get a 4. So now this is a normal way to identify the size of the array if there are so many elements are there in the array. Okay. So to find out the size, we can use this kind of calculation. You will get a size of the array. So finally, what is the size of this array? The size of the total elements in this array. Total elements are 4. So by that way, we are able to access the size of array. After that, I am calling it some function. Some function, their actual parameters are your array with 4 elements, and next one, size. Just you pass the array name. Whenever you pass the array name, the receiver, the definition of formal parameters should be a pointer, because I am not passing the complete array. I am just passing a name. Whenever you pass a name, here we can able to use another array or else a pointer variable. Anything we can able to use. Now there are 2 parameters are array and size. Now the function is going to be called to here. Function is called to here. Now what we have a first parameter? The first parameter is a pointer variable. This pointer acts as the base address of this array. Next one, size variable. The size will transfer from receive the value from this size. So size is become 4. Now here it is become 4 value. This array stored the base address. If the base address is the 2000 or 2000 value, 2000 address has been stored in this array. Okay. Now we want to run the iteration based on the size of variable. Now sum is equal to sum of array elements. We want to basically perform sum of array elements. So what is the I value usually? When I is equals to 0, that array, this pointer array is for the base address. The base address plus 0. So that is become a 2000 address will be accessed. Now 2000 address nothing but some value it is equals to 3. This is equal to 3. Now 3 plus 0. Next, whenever I is equals to 1, so I is equals to 1 nothing but 2004. The next value is become a 2004. The 2004 value is equals to 4 value. Okay. Next sum 4 plus 3, 7. Next, when I is equals to 2. So again, base address plus I is equals to 2 now. So nothing but it is become a 8. Okay, 2 into 4, 8. So it is become a 12. So what is the value? 5. It is 5. It's 5. So like that, every time we are access the array element by using pointer variable, and we are following this kind of notation. We are not following the array plus plus notation. We are following this notation. Okay. So by this way, the array base address will not be changed. But meanwhile, we are shifting from one address to the other address, and we are able to access the element value, and we are performing some operation. And finally, we are returning the sum value, and here there we are printing the sum value. This is the sum of array elements, but access the array elements by using a pointer. Next, we can able to access a string also. But here we are purely using the character string by using the percentile C. Okay, what is the data type of a string? Character type. So now what is the input to string value? Hello world. There are so many characters are there, 5 characters, 6, 7, 10, 11, 12, 13, 14 characters are there. All the characters we can able to access it once by using a percentile yes. But whenever we are using a percentile C, what is the difference between percentile S to percentile C? Whenever we use the percentile S, all the character will able to access at once. Okay. Whenever we are using percentile C, we can able to access character by the character. Character by the character. That's it. That is the different one. Basically, things whenever we want to process this thing, we are using the percentile S only because we want to print as a hello at once only. We don't like to print your thing like a H1, E1, L1, L1, O1 like that. Okay. But this percentile C processing such a way itself. Character pointer, character. What is the array type character? How many bytes to store the one character? One character, 1 byte only. Okay, na? So 1 byte. This is 1 byte, this is 1 byte, this is 1 byte. Each character stored in a 1 byte. Now the base address stored in a pointer. Okay. Now we want to print the value. So now we are able to travel over this corresponding array. This array contains so many number of characters. The first one is a H value, second one is a E value, next one is a L value, O value, and followed by comma, word like that we have. So this is the first byte address. Okay, example it is a 20 address అనుకుందాం. The next one is it is a 21 address. Next one is a 22 address. Next one is a 23 address like that. We have a addresses because each character storing a 1 byte of memory. Okay. So now what is the last character will become a class 0. It represents the end of the character until uh, the pointer, whatever the character, it not become a null character until we can able to access a pointer variable. So until we can able to use a character one by one by using a while loop. Now, what is our base address pointer? The base address print the first edge. Okay. The next we are incrementing the pointer address. This is an address increment. It is a address increment. If you keep an indirection operator, that will become a value increment in that address. Okay, now this is the only address increment. Address increment nothing but our control shift to the next address 22. Now, obviously, that base address will be changed in the pointer variable. If the pointer variable address is at 20, now after incrementing, the value will become 21. Value will become a 21. Now, 21, again, control will move to the condition. After condition, again, it is print. So, next one is a hello will, E will be print. Again, pointer plus plus means it will be changed. The base address will be changed. 22. Whenever you increment the address, obviously the pointer variable address will be changed, modified. It's not like a previous program notation. Okay. Next one, like that. The iterations will be continue until we reach a corresponding null character. Like that, all characters will be print one by one by using the control C notation. Okay. So next one, to print a multiplication table. Multiplication table. So here also, basically, we process the shifting of address by using the pointer plus plus. Pointer plus plus will also reflect the address increment value in the pointer variable, modifies the pointer variable value. Let us consider the pointer base address is just something like a 2000. 2000. What is the 2000 base address? Now it is pointing to the corresponding first value. Okay. So it is our pointer variable. It is our pointer variable. It is pointing to the base address. Now, obviously, we can able to find out the size of a array. So the size is become 4. Now it is pointing to the base array. Now we want to perform the multiplication table for the array elements. Okay, now every time if the array element is a 2, then multiplication table will be print for the 2. If next array element is a 3, 3 multiplication table. Next element is a 4, 5 multiplication table. Like that we want to print. So I is equals to, so that we have a inner for loop and outer for loop. So outer for loop able to access the element one by one. Inner for loop will multiply 1 to 10. Okay. It is very easy program. When I is equals to 0, what could be happen? When I is equals to 0 uh, and I less than size, because we want to access element by the element until reach the last element. So we should increment for every time. Now, what is the first element? Multiplication table for what is the first element? We will get a first element as a 2. First element 2 we got a first element because first element only identified by the pointer variable. Okay. The next for j is equals to 1 and j less than or is equals to 10. We want to multiply 2 into 1, 2 into 2, 2 into 3 like that. So 2 into 1 like that. So 2 into 1. Now what is the first print value in the first iteration in the inner for loop? Pointer, the 2, comma 1, 2 into 1. Okay. So means it seems like output is seems like a 2 into 1 is equals to 2. So where it is multiplying your pointer value in the first iteration, it is become a 2. So always multiply with 2 into 1, 2 into 2, 2 into 3, 2 into 4 until this inner for loop terminate. After inner for loop terminate, again control will move to the increment. Now increment and condition verify, condition true. Next it is enter into the inner for loop. So nothing but whenever it is incrementing, where you will get your pointer values become, so pointer also incremented. So before go to the, remember before go to the outer for loop, so we are incrementing the pointer, and increment the I value. So by that, whenever pointer variable is incremented, then now pointer is pointing to the next element. Okay, now which can be modified to the 2004. 2004. Okay, 2004. 2004 nothing but 3. So now the next time inner for loop will perform the 3 into 1 multiplication, 3 multiplication table until we will get a 3 into 10. Okay. After inner for loop, again we are coming to the outer for loop last statement, that is a p plus plus. Outer for loop last statement is a p pointer plus plus, and it is again increment the value. So means the pointer variable modified with the 8, 2008. So 2008 nothing but inner for loop will print the fifth table. Again pointer plus plus. Again it's increment the base address, nothing but base address of fourth element will updated in a pointer variable that is become a 2012. So like that, I think you understand how we are able to access each element in the array with the address wise as well as a value wise. So in the next video, I will explain about 2D array.